Good day my friends, and welcome back for another video. Today we are probably going to do the last video on the end-fed half-wave antenna, at least for a while. But yeah, in the past two videos I experimented a little bit with the 49:1 impedance transformer, and I said that I'm going to return and modify the antenna. We're going to make it work from 80 to 10 instead of 40 to 10, and for that we're going to use this inductor. We'll speak about this one in a little bit. And I said that I'm going to replace the antenna wire with the silver coated copper wire, but I haven't done that yet just because I don't have yet the silver coated wire, but I'll do that in the future just because I had this tip that it might improve at least the reception, and I'm curious to see if it's true or not. So once I have those results, I'll probably end up writing a blog article about the antenna, and I'll speak about the differences, if there are any. If I'm using a silver coated wire or just a simple wire that I'm using right now. So let's get up there really quick, talk a little bit about what I have right now, the setup that I have right now, and after that we'll talk about some coils and inductors. So I haven't changed anything on the impedance transformer. Probably I just squeezed the turns a little bit more, trying to see if I can improve the SWR on certain bands. But I just wanted to say that last time I didn't have the chance, and I did it right now because it was raining and it was also late at night. But I actually placed a little piece of wire that goes from the braid of the coax to this screw over here. It's the spot where I'm connecting the counterpoints, and for this antenna in particular right now, because it's 40 to 10, I used a 2 meters long counterpoints. Right now, because we're going to modify the antenna and we'll get it to work from 80 to 10, then the length of that counterpoints will be 4 meters. And because today we're going to talk about the compensation coil, which I spoke about in the last videos. This is the gimmick capacitor, the way I call it, because I think that's pretty much what it is. It's just a little piece of wire which is about 15 centimeters long, that I cut it more and more and more, and until I get the result that I desire, and I get the antenna to resonate a little bit lower on the 10 meters band, 50 meters, 20 meters, and so on. So yeah, it will pretty much bring the resonance point a little bit lower. It will also affect the main band. So in our case right now, the way this antenna is built for the 40 meters band, it will also go a little bit lower on the 40 meters band, but it will have more effect on the 20 meters, 15 and 10 meters band, and so on. So because today we're going to modify it and make it work for 80 to 10, it will be the same on the 80 meters band. So let's get down and talk about the coils and the compensation coil, which is equal to this gimmick capacitor. Of course, I'm not going to continue without saying thank you to my friends at PCBWay for always sponsoring and supporting the DX Explorer channel. Don't forget, they have great PCB prototyping services, PCB assembly, SMD stencils, CNC, 3D printing, and a lot more available for you. Also, have a look at the projects that I designed so far. All the PCB boards, they are available over there. You'll have a link in the video description for that. And you can always order either the simple plain PCB boards, or you can also order the assembled version. And don't forget about the module store that they have available, where you can find interesting things for your projects, and they might be very useful. So have a look at that as well. And if you don't have an account for PCBWay, have a look in the video description. You'll have a link where you can register and you'll get a discount on your first order. As I'm always saying, PCBWay is the way. So right now let's talk really quick about the inductor that we're going to use to artificially extend the length of the antenna and get it to resonate on the 80 meters band as well. But we will also talk about the compensation coil, which is a totally different thing. But I noticed from comments around, online and on YouTube, that many people are confusing these two. So this one has one function, and this compensation coil, which right now is just a piece of PVC pipe, but it will become a coil in a little bit. This one has a totally different use. So this is what we normally use to extend artificially the length of the antenna to get it to resonate on the 80 meters band, and technically most of the time this one has 110 microhenries. And this is because we're trying to keep the length of the antenna as short as possible, so we will fit in a small backyard. If you have a long backyard and you have enough space, then don't use this coil, use 43 or 41 meters of wire, depends how high you put it, and you get it to resonate well on the 80 meters band. But if you have that space, it's better to use that antenna because you get better results and more bandwidth on the 80 meters band. But in case you don't have and you have a small antenna, a small backyard, this is the solution. So normally if you're using the 110 microhenries after the inductor, you're going to place a wire that is somewhere around 2 meters long, but you can go actually as low as 55 microhenries, but the length of the wire will increase. It will be somewhere around 3 to 4 meters maybe. You'll see that when you actually tune the antenna. But the reason why you can use a lower value if you have enough space to extend that antenna is that the bandwidth on the 80 meters band will also increase a little bit compared to the 110 microhenries. Now in my case, this one has 85 microhenries. I measured this one earlier, and I built it using 0.8 millimeters enamel copper wire, and I put 120 turns. So yeah, I ended up with 85 microhenries. I didn't even calculate anything. I just put the turns, and then I measured, and I said whatever I have, that's what I'm going to use. And once I finished building this one, I just wrapped it up with some insulating tape, and I sprayed everything with a little bit of varnish to protect it from the weather, and that's what we're going to use. I actually used this method in the past for another antenna in my older QTH, and it seems to work pretty well because I used that one for about 3 years, and it stayed pretty well in the sun and in the winter, and when I took it down it was pretty much like brand new. So this is a new one. I wanted to use thicker wire, but I don't have. If you use thicker wire, like somewhere around 1 millimeters maybe, also it will help on the improving the bandwidth on the 80 meters band. But anyway, we will probably end up having to use an ATU to tune the antenna perfectly in the exact portion of the band that we'd like to. Now the compensation coil, this is a different thing, and I'll take you down to the antenna wire and we'll speak about this one over there. But many people are confusing these two, but they have totally different uses. I was happy that I don't have rain anymore, but I think it's right behind me towards the mountains, and it's coming over here, so I'm going to try to install this antenna and finish everything with it before the rain gets here. So let's talk about the compensation coil. So I have here a 2.5 centimeters in diameter PVC pipe, the compensation coil. So if this 110, when in our case today it's going to be 85 microhenries inductor, will get installed towards the end of the antenna, the compensation coil over here will be installed in the side where we connect the antenna wire to the 49 impedance transformer. And because today we're going to build the 80 to 10 version, we're going to measure 2 meters from the point where you connect the antenna to the 49 to 1 impedance transformer. We measure 2 meters. Right now I'm just going to give you an example, and after that the compensation coil, it's a couple of turns on this PVC pipe. Usually it goes from 3 to 8 turns maybe, because it depends of the diameter of the PVC pipe that you're using, and also the thickness of the antenna wire that you are using. So it will definitely have a different inductance. And this compensation coil has the same effect of the gimmick capacitor, the little piece of wire that we spoke about earlier. And yeah, you get to test the number of turns. Maybe you can add some more, you can remove a couple of turns, and see how you can bring down the resonant point on the 10 meters band, 15, 20 meters, and so on. And in our case today, even the 40 meters band, because it will affect that one as well. and definitely it will also affect the 80 meters band, but just a tiny little bit, not as much as it does on the rest of the bands. So this is the compensation coil, and this is the inductor that we're using towards the end of the antenna to artificially extend the length of the antenna. So people are confusing these two very often, I realized. So yeah, they have totally different uses, and it's good not to confuse them. So that's the reason why I wanted to even make this video today, to specify this, because even though I actually made a video in the past on this, yeah, people still seem to confuse these two. So right now I'm trying to tune the antenna for the 40 meters band without any gimmick capacitor and without any compensation coil, strictly the antenna wire, no 85 microhenries inductor, nothing. So it's just a plain wire, and it's resonating a little bit too low right now, so I'm going to try to shorten it a little bit. See if I can get it to resonate somewhere on the upper side of the SSB portion of the band, just because once I'm going to place the gimmick capacitor or the compensation coil, it will go a little bit lower, somewhere in the middle of the SSB portion of the band. So let me raise it up, and we'll go do a measurement on the nano VNA to see how well it's tuned. All right, let's go inside. As you can tell, it's not very high, probably 2 meters 70, 2 meters 80. So the SWR definitely is not going to be so good compared to if I would have the antenna properly, like maybe at least 6 meters high, like the way I used to have it in the older QTH. Anyhow, let's go check the SWR. So right now the antenna resonates in the right point where I want it, 7.130 megahertz. The SWR is somewhere around 1.4 to 1, which is okay considering the height of the antenna. And now we're ready to install the 85 microhenries inductor and the rest of the wire, so we can tune it on the 80 meters band. For now, we don't care about the rest of the bands. We tuned the antenna for the 40 meters band, which was the main band until now, and right now we're going to take care of the 80 meters band, and after that we'll go through the rest of the adjustments. Okay, so I placed the inductor over here. This wire is the one that we just tuned for the 40 meters band, and this one, oh, I'm getting I'm getting varnish on my fingers. It didn't dry completely. And this wire, it's about 4 meters long, and this is what we're going to start with to tune it for the 80 meters band. And of course after that it will probably end up a lot shorter. One detail that I wanted to show you over here, where you have the connection between the antenna wire and the wire from the coil, you can actually solder those two to make sure that you have a good electrical connection over there. I haven't done that right now, just because, remember, I'm trying to replace the regular wire with silver plated wire later on. So yeah, you can solder these to make sure, even though you use a screw, solder them together, because in time that connection might corrode, and yeah, you'll have some bad contact. So let's install it, and I'm going to trim it and adjust it as much as is needed until I get it to resonate properly on the upper side part of the 80 meters band. So after I tuned the antenna on the 80 meters band, we are somewhere around 3.656 megahertz, and the SWR is somewhere around 2 to 1. Unfortunately, the best, but it's the height of the antenna, there's not much I can do. And the impedance, as you can tell, it's only 27 ohms. So let's go on the 40 meters band really quick. I'm going to go to 7 megahertz, stop. I'm going to go to 8 megahertz because yeah, as I could guess, it resonates a lot higher right now, so it's somewhere around 7.4 megahertz. Let's go to the 20 meters band, 14 megahertz, and stop. I'm going to put 15 megahertz, and here as well it resonates a lot higher. So what I'm going to do right now, I'm just going to leave the nano VNA and the camera recording, and I'm going to go and place that gimme capacitor, that little piece of wire that I'm usually using, and I'll try to bring down the 20 meters band somewhere around 14.2 megahertz. So let me go outside and place that gimme capacitor, which is pretty much this little piece of wire that I'm just going to attach at the same point where we connect the antenna wire to the 49:1 impedance transformer. Alright, I'm back to check the SWR. So it's still not low enough. That means I need to place a longer piece of wire. But yeah, let me go do that. What's the SWR? 1.3 to 1, not bad. So let me go place a longer piece of wire. Alright, so now it resonates exactly what I wanted. So I have about 15 centimeters of wire that I'm using as that gimme capacitor that I described earlier. So right now let me go to start 14 megahertz, stop 14.35. Now the SWR is oscillating because my antenna is really windy outside and my antenna is moving up and down. But it's not that bad. So 14.2 megahertz and the SWR, it's about 1.2 to 1, not bad. 41 ohms impedance. So let's go back to the 40 meters band and let's see what we have over there. 7 megahertz, stop 8 megahertz, and let's see right now what we have. Is it low enough or I have to go even lower? Yeah, it still resonates way too high. So I wonder what should I do. Let's go on the 80 meters band. 3.5 megahertz, and let's see how much it affected the 80 meters band, and stop 3.8 megahertz. So right now it still resonates on 3.6, so we're not very far from where we were earlier. 3.650 almost. It didn't move very much, so that means I can play around even more. But I think you got the idea, because that's what I'm trying to show you. Let's go to 28 megahertz and I'm going to put 30 megahertz. Let's see where the 10 meters band is. So the lowest point is somewhere around 28.6, and the SWR it's 1.8 to 1, but of course because of the wind. But I think you get the idea. So with that gimme capacitor the frequency went a lot lower. If I wouldn't use that one, probably I would be outside of the band with the resonating point on the 10 meters band. But I think you could see the difference on the 20 meters band. So I'm going to leave the gimme capacitor right now, and I'll do another test with the compensation coil to see the difference. So I'm going to go back on the 20 meters band, 14 megahertz, stop 14.35. Actually, let me go 15 megahertz. So we're going to stay here, and we'll go outside to do the thing with the compensation coil. Okay, so earlier on the 20 meters band we were somewhere right in the middle of the band, and right now I installed the compensation coil, and I have 8 turns on the 2.5 centimeters 14, what I'm doing here, 14.35 on 25 millimeters diameter, and what we have right now on the 20 meters band is resonating somewhere around 14.5, and the SWR is a lot higher. So I guess I should put more turns on the coil, but I'm gonna tell you what I'm not going to do. I'm not going to waste my time with a compensation coil just because I already did that 3-4 years ago, and I spent about 2 days trying to get the SWR perfect by raising or lowering the number of turns, and it's very annoying. And for that reason I prefer much more the gimme capacitor option, because it's a lot easier to tune it. I'm just going up the ladder, I'm cutting like a centimeter from that wire, I tune, I come back, I check the SWR, I go back, I cut a little more if needed, and yeah, so you get the idea. But at least you see how this works. So the compensation coil pretty much does the same thing as the gimme capacitor, except that it's just a waste of time, I think, to be honest. It takes way too long until you get it right, until you get the right number of turns. So let's not waste any time. I'm just going to go tune my antenna perfectly, as the best I can, with the gimme capacitor and the length of the antenna, and we'll be back to close this video. But I hope you learned something from all these experiments that I tried doing. So I think it's enough for today. We've been experimenting enough. I'm going to continue to do some adjustments to the antenna until I get a better SWR. We'll see what's the best that I can get, considering that the height of the antenna is not so good. So I would recommend you to go for at least 4 or 5, maybe even better. It would be somewhere around 6 meters. That's what I've had in my older QTH, and the antenna performed really well. So yeah, I have it all all set up, even though it's actually a temporary setup. I'm actually just experimenting for you guys to make the videos. I'm going to try to see if I can move my caravan soon into a new location, and the final location probably, and yeah, we'll have the final installation over there, and probably I will try to put it a lot higher. So right now, as you can tell, I don't have any compensation coil over here. It's just the brown wire. I cannot zoom in over there, but maybe you can see it. The brown wire, which I'm using as a gimme capacitor to lower the frequencies a little bit, to lower the resonant point on the 10 meters band, 20 meters and so on. And the blue wire, which comes down, and this is the counterpoise, the 4 meters wire used as a counterpoise. And over here we have the 85 microhenry inductor that we're using to extend the antenna to work for the 80 meters band. and yeah, this is the system that I'm using to keep it up. So as you can tell, it's not very high. I'm going to come back on Sunday with a video on the ATU, and right now I'm just going to go inside and see if I can make some adjustment, trying to get some better SWR. I'm still having some issues right now with the 80 meters band and the 40 meters band. So I'm tuning the antenna for the 80 meters band. Doesn't matter if I tune it on the higher portion or the lower portion. The gimme capacitor doesn't seem to affect the frequency, the resonant frequency of the antenna on the 80 meters band, but it does affect the 40, 20 and so on up to 10. Unfortunately, if I tune the antenna to work well for the 20 meters band and up to the 10 meters band, the 40 meters band seems to be off. If I tune it perfectly for the 40 meters band, then the 20 meters band and everything else up to the 10 meters band seems to be off. So it's like right at the edge of the band. So I don't know what's going on, but I'll see. Definitely the height of the antenna has an influence, but I'm planning to build an ATU anywhere, and I'll see you on Sunday with that video. We'll do some more experiments with the ATU. So thanks so much for watching. I hope this helped. Remember, by the way, the length of the wire that I placed after the 85 microhenries inductor turned out to be 2 meters and 80 centimeters. So yeah, it wasn't as long as I was thinking that it will end up. So it's okay. It's good for a short garden. Now, keep in mind that this antenna, it's a compromise. It's not the perfect antenna, but it's good. It's multi-band, it's useful, it's easy to build. Takes a little bit of time to adjust it properly, but you have a lot of bands available, and if you're using an ATU, you pretty much can use the antenna for any HF band from 80 to 10. And with a little bit of modifications, you can even use it for the 160 meters band. But yeah, if you want like good performance, you're probably gonna have to go for multi-band antennas. I don't know. I'm using the vertical for the 20 meters band, and I always have great results from that. Not that the end-fed half-wave doesn't offer me great results, but I seem to perform better on the X with the vertical for the 20 meters band, and it's a monoband antenna. But this one, the end-fed half-wave, works well for reception, for example. So yeah, it's a compromise, you know. But I'm going to build the ATU, and I hope I can tune it for the right portion of the band that I want to in each band. So yeah, I'll see you on Sunday. Thanks so much for watching, and have a fantastic rest of the week. 73 from Yankee Oscar 6 Delta X-Ray Echo.